This is lesson 6-1, solving a system of linear functions by graphing. So vocabulary for this particular lesson, first of all, we need to define a system. And a system is any two or more functions that apply to any given single situation. For our purposes, we're only going to ever be using two functions at one time. It is very rare that you would have three functions at one time in this course. We will look at a couple of problems with three, but most of the systems that we work with will have two functions. And for this particular lesson, we're going to focus specifically on the linear functions. Let's talk about consistency versus inconsistency in a system. A system is consistent if it has at least one solution. It's inconsistent if it has no solutions at all. Independent versus dependent in this situation. If a system is consistent, it has to be also independent or dependent, depending on the number of solutions that you get. If a consistent system is independent, it has exactly one solution. And this will happen the majority of the time for us, that we only have one solution with a linear system, and that would be where the two lines intersect. If it's dependent, it means it has infinitely many solutions, meaning that it's exactly the same line just mapped on top of one another. Here's your procedure for graphing a system of linear functions. First of all, make sure both of your linear functions are in slope-intercept form, meaning y equals mx plus b. That's important because that's how we graph functions. Second, graph both of your lines using the slope-intercept method. If you don't remember how to do that, you need to go back and look at your notes on slope-intercept form, which I believe is lesson 5-3. You have to label both of the lines on the graph with the original function. I'm putting that in capital letters for a reason. If you don't do that, you're going to lose points both on any assessments and the New York State Regents exam. Finally, state your results in words, meaning state if it's consistent or inconsistent, and if it's consistent, state if it's independent or dependent. If the system is independent, meaning that there is a point of intersection, circle and state your point of intersection. Sometimes there will also be follow-up questions to these graphs, and you need to answer those as well. Here's an example. We'll do it together. Pause the video at this point to set up your graph, as well as get your two equations into slope-intercept form. I'll start with the top one. I'll do this one in black. Getting it into slope-intercept form means I would subtract both sides x, and I'm going to tuck it in the front. So I have y equals negative x plus 1. For the second one, I have x minus y equals 7. Again, I'll subtract x from both sides and tuck it in the front. But now I have negative y equals negative x plus 7. And I'll divide by negative 1 on both sides. Remember that this negative 1 applies to both the x and the 7. So y equals x minus 7. I'm going to graph the black one first. My slope is negative 1 over 1. My beginning is 1, my y-intercept. So I start at 1 on the graph, and I'm going to go down 1 and over 1 all the way throughout. I'll create my line. Arrowheads at the end of both, and label it with the original function. I'll repeat the process for my one in red, starting at negative 7, and my slope being 1 over 1. can already see as I'm plotting my points that this graph is going to cross at one spot. Label my line. Now I will state that the system is consistent and independent, and I will circle and label my point of intersection, which in this case is 4, -3. If you're having any issues at this lesson, please make sure you are emailing me or consulting me in class.